Time to begin. Copy and complete the following mapping diagrams below. Write down the domain and range of each function. Okay, the rule is add 5. 6, 7, 8, 9. Okay, write down the domain. The domain is 1, 2, 3 and 4. The range is, anybody know the range? 6, 7, 8 and 9. Would you know how to do part 2 now? Multiply 2 by 2 and add on 1. First one's 5. Shh. Second one is 2 times 3 plus 1. Or sorry, 2 times 4 plus 1. 9. You know how to do the second one, right? Same thing.
Wait, the range not 5.
No. No, it's the numbers in the second one. 6 to 9. Okay, next one. Say what the following set of couples is a function. Okay, let's figure this out, okay? So I'm gonna make an ellipse like so. I'm gonna make another ellipse like so. I'm just gonna write them out. 1, 4. See what I'm doing? Well, actually you can't see what I'm doing, I'm not writing at the moment. 2, 5, 3, 6, and 4, 7. Let's do our arrows. Like this. Now, can anybody tell me why this is a function? This is a function because the same thing happens every time. Every time the input gets 3 added onto it to become the output. Is everybody happy with that? Now, what about this one here? If I was to draw this out, and 2, 3, 5, and 2 again. So 2 is already written down, isn't it? Now what about this one? It goes to 5, 6, 8 and 10. Say why this following sets of couples is not a function. Let's find out. 2 goes to 5, 3 goes to 6, 5 goes to 8, and 2 also goes to 10. It said earlier on that you're only allowed to go from one. You have to go from one value in the domain to only one value in the range. This means it's not a function, okay? Or it's not a linear function. Okay, because there's a different gap. There's no rule, is there? Can you make out the rule? There is no rule, is there? Or there doesn't seem to be a rule. So look, we'll just say it's not a function because the number 2 has 2 different values. As I said before, when it comes to identifying functions, when a function is represented by a mapping diagram as shown above, each element of the domain, here's our domain, maps onto one and only element of the range. In this question, the number 2 maps onto 2 different elements of the range, therefore it cannot be a function. You got it? Yeah? Okay, next question. Number 9. The rule for this function is multiply by 2 and add 3. Okay, multiply by 2 and add 3. Let's see what happens. 1 and 2. Okay, multiply by 2 and add 3. The domain of the function is, domain is another word for what? The inputs. Okay, multiply 0 by 2 and add 3. What do we get? 3. Multiply 0 by 1 and add 3. Or sorry, 2 by 1 add 3. 5. 2 multiplied by 3 add 3. 2 multiplied by 4 add 3. Oh sorry, 5. It's 5, sorry. 2 multiplied by 5 add 3. 13. Okay. What happens next? 1, 2, 3, 4. Okay, what's the range, guys? Range is what? 3, 5, 9, 13. What's the couples generated? 0, 3, 1, 5, 3, 9, and 5, 13. Handy enough, aren't they? Actually not too bad. Now, number 11. A function is defined as... That is fairly big. Right, a function f is defined as f of x is equal to 4x minus 5. The domain of the function is minus 2, 0, 2 and 4. What is the range of f? Let's do what we always do. Just quick, I just like drawing these because they're easy. Now that I've done that, I'm burned. You awake? 2, 4, right? And the next one is, what is the range? So what do we need to do? We need to multiply each number by what, guys? 4, and then take away 5. So here's me doing all 4 numbers now. Okay, what's the answer to the first one? Minus 13. Next one? After that? 3. And after that? 11. Okay, what is the range of f? Can anybody tell me? Okay, minus 13, minus 5, 3 and 11. What's the write it as couples? How do I write it as couples? Minus 2, minus 13, 0, minus 5, 2, 3, 4, 11. Okay, easy. I won't do that one, that's easy as well, isn't it? Just put them in and figure out what it is. It's easy. Number 15 might be hard though. 15. In the 3 times tables below, some input and some output numbers are given. By trial and error or guessing, find the rule for each function in the form y equals something. Okay. 3 turns into 2, 7 turns into 10, 5 turns into 6, and 6 turns into 18. Anybody see a pattern yet? Sorry? Multiply by 2 minus 4. Multiply by 2 minus 4. You're right, Dennis. But how did you figure it out? Can you even explain how you figured that out? Yeah, so Dennis is saying is 3 turns into 2, but 7 turns into 10. So if you do 2 multiplied by 3 minus 2, or sorry, what's it, minus 4, is it? That equals 2. 2 multiplied by 7 minus 4, what do you get? 10. 2 multiplied by 5 minus 4. And 2 multiplied by 11 minus 4. Anybody? 18. So that's how Dennis got that. So the answer for this question is 2x minus 4. 2 times the input minus 4. Let's have a look at the next one. Anybody know how to do the next one? I've thought of it. Anybody else have an idea? Yes.
Is it
Yeah. Go on, give it a go. Okay.
Is it multiplied by 3 and add 2?
Multiply by 3, add 2. Let's try it out. 3x plus 2. Let's see if it works. 3 times 1 plus 2 is? What is it? 5. 1 and 5, correct. 3 times 3 plus 2? Anybody?
11.
11. Well done, Farrell. 3 times 5 plus 2? 17. And finally 3 times 10 plus 2? 32. Okay, we figured this out now. Well done.